In this video, I'm going to focus on the complementary sets and shading the described region. So let's get started by answering questions which are shown. So here, as you can see, we have these two sets, set A and set B. Then if you are told to list the elements in A intersection B complement, so you have to deal with the things which are in the brackets. So the things which are in the brackets are this middle part, which is 1 and 2, and you're not supposed to list these two elements. So you're going to list everything which is outside A intersection B, so which is 4 and 3. As you have seen, I've written it here. So the next one, it's I'm going to write it by the left side here. Number 2, we have A complement intersection B complement. So as for this one, it's going to equal. So here, first we're going to list these sets step by step. Then after that, that's when we're going to write the answer. So let's list first the elements which are in set A complement. Set A complement is everything outside of set A. So everything outside of set A is 3. That's the only element which is outside set A. So it's 3. Then next we're going to list the elements in B complement. So B complement is everything outside B, which is 4. So B complement is equal to 4. So the next step, we are going to find the intersecting part. As you can see, 3 and 4, there are no common elements which belong in both sets. So this A complement intersection B complement is equal to an empty set, which is represented by this symbol or this. So this is an empty set. There are no elements which are found in both B complement and A complement. There are no common elements which are found in it. So let's go to the next question, which is list the elements in A complement union B. So number 3, A complement union B, complement union B. So even for this one, we're going to go step by step. So it's going to be A complement. So the elements in A complement are, we listed it on the previous example, it's 3. And the elements in B are, so when we go to our set, the elements in B are 1, 2, and 3. So we're going to list them here: 1, 2, and 3. So now let's find the union. So it means everything together. So the union of A complement union B. So A union B. So union means everything together. So we're going to combine these elements all together. So the answer is going to be 1, 2, 3. So this is the answer for A complement union B. So let's go to the next question. The next question, which is question 4. So question 4, it's A complement union B complement. Okay. Question 4. AV. A complement union B complement. So A union B, A complement union B. So we are also going to list this set step by step. So we're going to start with A complement. Set A complement is equal to, even we have listed it on the previous example. So A complement is 3. So now let's list the elements in B complement. So B complement, everything outside of B, it's 4. Complement is equal to 4. So union means put everything together. Putting everything together in ascending order or alphabetical order. So this is going to A complement union B complement is equal to 3, 4. So I want you to see if you have noticed something. So if you have noticed A complement union B complement, it's the same answer with this the first question, which is A intersection B complement. So these two are equal. So you need to note this down. A complement union B complement is equal to A intersection B complement. So let's go to the next. Oh yeah, let me also tell you another one. You need also to note this one. A union B complement is equal to A complement intersection B complement. So this one here, A complement A complement intersection B complement, they are the same with A union B complement. And if you can just go back for you to prove that they are the same. So this one, A union B, the elements of A union B should not be touched. You should only get the elements which are outside A union B. So A union B, it's all these elements now complement. So everything outside of this, so it's an empty set. This is why this question here was, the answer was, it's an empty set. So have you seen that they're both equal? So let's go to the next question. I'm going to put it by the right side. So the next question here is A union B complement. So the answer is already known. That's what I'm talking about. So A union B is the same as A intersection A complement intersection B complement. So this, we're going to go everything outside A and B, which is an empty set. So this was number 5. So the last question on the complementary set, which involves two sets, it's this one. We have A complement intersection B. So let's list the elements on A complement. A complement is equals to 3. It's 3. And B, the elements in B are 1, 2, 3. So 1, 2, 3. So let's now get the elements which are found in A complement and in B set B. So we can see it's 3. So A complement intersection B equals 3. You can even see it says A complement, so don't touch the elements in A, everything outside B only. So this is why it's 3. Now let's go to the next question. So here is the next question. Now this question, we have only added another set to make them 3. So the concept is still the same. So let's list the elements in A intersection B intersection C, then complement. So I'm going to write it here. Number 1, A intersection open B intersection C complement. So just as we did the previous examples, that's how we're going to do this also. It's going to be step by step. So let's first list the elements in set A. So set A is equals to, so the elements in set A are A, C, D, and F. So these are the elements of set A, and let's now list the elements in set B intersection C complement. Open B intersection C complement. Let's list the elements in this set. So the elements in B intersection C complement. So we're going to go B intersection C. Here is our B and C. So the intersecting part, it's this one here. So we're just going to hiding this portion here. Then the elements which are left, those are the elements which we need. So everything outside it, so which is E, D, F, C, G. So this is going to be C, D, E, F, and G. Close. Let me just check. C, D, E, F, G. C, D, E, F, G. Okay. So now, since it says intersection, now let us list the elements which are found in both set A and in open B intersection C complement. So A intersection B intersection C complement is equal to, so in set A there is A, in set B intersection C complement there is no A, there is a C in here, so let's see. D, there's a D, F, there is also F. So these are the elements which are found in A intersection open, B intersection C close complement. So this is the answer for this question. So the next question, it reads, the next question is number 2. It's A complement intersection B intersection C close. So the same. So let's list the elements in A complement. A complement is equal to, so all the elements outside of A. So this set will be removed, and the remaining, which is B, E, G. B, E, and G. So these are the elements in set A complement. Then let's list now the elements in set B intersection C. B intersection C is equal to, so B intersection C is this part. So the elements are A and B. A, B. So next step, A open, B intersect, C close. So the next step now, we're going to list the elements which are found in both A complement and B intersection C. So the elements which are found in both, it's only B. So this is the answer. The last question, after this question, we're going to the shading. The last question is A complement union open, B intersection C close. So let's list the elements in A complement. Yeah, it's here, B, E, G. Then next, the elements in B intersection C. B intersection C, it's here, it's AB. A, B. And now let's unionize them. So we put them together in alphabetical order, which is A complement union B intersection C close is equal to, so it's going to be A, B, E, and G. Okay, now let's start shading the described region. So we're going to start with the basics, which are shading A intersection B. So A intersection B, it's this part on the middle where the elements of A and B, they share these elements here on the middle. So this is the answer. Then for A intersection B intersection C, it is the portion where A, B, and C, they all share the element, which is this middle part here. I hope it's visible. And the next one, union, means everything all together. So A union B means everything in B and A. So we're going to shade everything in B and A. And as for A union B union C, it also means everything in B, everything in A, and everything in C. So that's it for these examples. Now let's include the complement and see how we're going to do this. So let's say you have a question, they tell you to shade the region C complement intersection open A intersection B. So for this one, you might want to make a rough set where you are going to shade. So mine, I'll put it just by the right side here. So here is my rough set. This is A, B, and C. So we're going to make actually two. Here is another rough set. This is A, B, and C. So we're first going to shade C complement. So C complement is everything outside of C. So this set is for C complement, then this one will be for A intersection B. So this now it's going to be, so C complement is everything outside of C. So everything outside of C, we're going to shade it. Everything outside of C, which is this. Everything outside of C. Now let's shade B, oh sorry, A intersection B. So A intersection B, it's this middle part here. So just as we were doing the previous examples from the complementary sets where I started, we were saying that after that we have to get the elements which are found in both sets. Now even for this, we have to only shade the area which are shaded for both these rough sets, which is this one for the down part. So on this one, I'm going to make it darker. I hope it's visible. So this part, it's shaded on the A intersection B set, and when you look also here, it's also shaded. It's also shaded. Have you seen this region? It's also shaded. Even here down, it's also shaded. So that's the region we are interested in. So this is the region which I'm going to shade in my final set, which is here. So this is the answer here. That's where you're going to shade. This is where the shading is supposed to go. So for the next one, so let's go to our next question, which is shade the region A complement union B. So as for union, they are easy. You just have to go step by step instruction. So this one, there is no need of making two rough sets. We just go direct, though just for me, so that this one should be clear, the region which will be shaded. So I'll just write it by the side here. So these are the two sets. This one will be A, this one will be B. So as we said earlier, where I told you to note, I told you to say that A complement union B complement is equal to A intersection B complement. So here we already know A intersection B complement is everything outside here. So I'm going to show you how it's like. So first we're going to go step by step. So A complement everything outside of A, which is everything outside of set A. So that's A complement. Now I'm going to use a blue color, though it's not very visible, but I hope you see. So B complement, everything outside of B. So everything outside of B, everything outside of B. So everything which is outside of B. I hope it's visible. So the one in blue, it's for B complement, and the one in black, it's for A complement. As you can see, the only region which is not shaded is the middle part where they intersect. So this is why I said that A complement union B, it's equal to A intersection B complement. So now let's shade our final shading, which will be clear and neat in our final set, which is this one. So this is the region we're supposed to shade. So this is the answer. So we're going to go to the next step of shading. So here is the next Venn diagram. We're told to shade the region A complement union open B union C complement. So here is one thing you need to note about this part, because it's going to be tricky. So I advise you to do this. So this complement, you're supposed to distribute it inside of the brackets. So it's going to be like this: A complement union open, it will be B complement C complement, like this. Then when you distribute this complement, the sign, the operation here will change to intersection, which proves that point which we said that that point at B union C complement is equals to B complement intersection C complement this. So this is the same thing as this. When you distribute, you change the set operation in the middle. So I've changed it to intersection. So now this is going to be easy for us. First, we're going to shade. So I'm going to make a rough set by the right. So this, and this. This is A, B, C. Another rough set here. A, B, and C. So after making these rough sets, now first we're going to shade in this top one. We're going to shade A complement. For the down part, we're going to shade B complement intersection C complement. So now let's shade. A complement is everything outside of A. So this is everything which is outside of A. This is a region which is outside of A. And for this one, the down part, we're going to shade the region which is outside. Oh, sorry, I forgot one point here. So here, after doing this, we have to distribute for this to be easy. we have to distribute, so it's going to be okay, even like this it's the same. It's better we distribute so that you understand what I try to mean. A union, so we're going to distribute this A complement union with this, and with also this term, and this set operation on the middle will remain unchanged. So A union complement, when you distribute it with B, it will be B union complement. The sign will remain on the middle, which is the intersection, and when you distribute A complement union with C, it will be A union complement and C complement. This one is tricky. This is why I advise you to use this method. So now I will just we have to forget about this top set, because it will be something else. So for this one we'll shade for the down part, this one, that's the one we'll use. We're going to shade A complement union B complement. We're going to shade this, and for this set here by the side, we're going to shade A complement union C complement, this. Then after that, then we'll get the area which is intersecting, the area where both regions are seen. This is why I've told you to use this, but I also tell you that you can also do, there's also another method which is direct, though I advise you to follow things step by step so that you should know how they are done. So now A complement, it's this, everything outside of A, everything outside of A, and for B complement I'll use a blue color, hope it's visible. B complement, so that is for B complement. So the only area which is not shaded is this part where these two intersect, this part. The next one here, we're going to shade A, we're going to shade A complement union C. So A complement is everything outside of A, and B complement, oh sorry, C complement is everything outside of C. Everything outside of C, like that. I hope it's visible. Let me darken this a little bit. Everything outside of C, everything which is outside of C. And for this one, the only part which is not shaded, it's this one. So we have these shadings now. Now we want to see the region in which both A union B complement, A complement union B complement, and A complement union C complement, they have the same shading. So as you can see in this set, some are shaded, the others aren't shaded. So the only region which is shaded for both sets, it's the outer region, the outer part of the sets, the outer one. That's the region which is shaded in both the sets, this and this. It's the outer region. So this one, A complement everything outside of A, B union C everything outside B union C, so everything which is out. So this is the shading. So this is the shading for B union, B A complement union open B union C complement. So we have this set, we have to shade this set, we have to shade the described region which is A union B complement. So we have to shade this region. So and this is the last example for this video. And so A, we're going to shade A set A, which is this, and B complement everything which is outside of B. So there is no need of shading the outer region, just this. So thank you for watching. I hope this video helped you, and please remember to subscribe and like my video. Thank you again.